Hey guys, today lecture is lecture 4. We are in electromagnetism. So let's start. So you guys, know about insulator and dielectrics. Actually, you guys should know insulators about kind of, mm, you guys can explain, you know what I mean. So what happened? So what I mean is you guys know this insulator, like you can imagine it's prevented the current, you know, prevent current. But instead of a dielectric, you guys don't know, exactly. As I said earlier, if you guys don't know and exactly don't know the concept, and you guys know like abstractly, so which means we don't know, which means. So if I could explain it to others, which means I know this. Let's go together. So insulator is I used in electrical equipment to separate electrical conductors without allowing current through themselves. Yeah, which means prevent current, right? Look at that here. Yeah. So which means it's not resistor, you know what I mean? Just prevent current, but there's another purpose, right? To protect us, or just allowing, didn't allow to current, current to follow the current. There's some purpose. So which we use for insulate, like for safety, like right. And instead, dielectrics. So, in the circuit, there's RLC, right? So dielectric is, C, capacitor. So it is mostly commonly used for energy stores in capacitors. So main purpose is, is that store energy. More specifically, I could say the dielectrics draw the current here, from outside or somewhere, draw the current here, drag, I mean, and the store like battery, you know what I mean? So you can see here, there's a two plate made by metal, conductive plate, and between them, there's a dielectric. Let's go over. So electric conductors, as you can see here, is copper, steel, silver, and electrical insulators, rubber, glass, diamond, drywood, like that. And insulators here, jacket insulator here, and the primary insulator here, right? So let's go more over. So since both of them, insulator and dielectric, they have a same material, for example, paper, but they have a different purpose. The differences is insulator is prevent current, from the safety, for example, but instead dielectric, it try to do, get store the energy. That is differences. So since these two, dielectric and the insulator, has the same material, so its a property is having a non-conductor, as you can see, non-conductor characters. You guys already know conductor and non-conductor. Conductor means, the current is flow really well. More specifically, there is a transformer core, right? So we use a core like the materials are steel, right? So the current going through where? For example, here, sorry. Here is the Bohr's atom, right? And from the outer energy, it affect. And as I said, the nucleus part here, it's kind of a heavy, right? So it doesn't, move generally. So the electrons, they move. But in conductor, the free electrons, just escape from the atom. It gotta be a charge. It has its own energy. You know what I mean? So, but instead, uh, insulator, property like a dielectric or insulator, it has, little bit different properties. Look at that. We say here, insulator have a tightly bound electrons, which means cannot, easily move. Which means they could move, but what I mean is they cannot escape. You know what I mean? Like they don't being free electrons generally. You know what I mean? Easily. So that's your differences. Let's look at more. Here, look at that. Here's atom, right? So this state now it doesn't have a electrical meaning because neutral itself, right? But from the outer energy like heat or wind or whatever thing, yeah, it affect and it gotta be split. You know what I mean? So we say this is getting the charge. We say specific word electrification, right? So getting electrification, it's gonna be like this. As I said, the nucleus part here is heavy, so it doesn't move. So the electrons, comes down. For example, the direction is doesn't matter. Okay. So for example, here's nucleus, but electrons here, right? Electrons just moving down. For example, in this picture, you got it. So next picture here, look at that, like this. But in this case, we connected DC voltage. DC voltage is the outer energy, right? So here's a negative part, and here is a plus part. So it attracted the other side, inside of the dielectric, they attract the electrons. That's right. But they cannot, they cannot being like a free electron. That's it. So we say this is a polarization, right? It's gonna be the plus particles here, minus particles kind of separate, right? And when we say this looks like, only plus and minus. So more specifically, the polarization is makes electric dipole. That's it, If you guys understand that this concept, it makes, guys, help you guys to understand more about capacitors. Our knowledge is, accumulate, and make forest someday. So believe me, you know what I mean? Because I also did. And, since I, always prepare for this, I thought I know everything, what I learned. But since, trying to do teach is a different part. So I could also, while I'm preparing this, also I could memorize and I could find out specifically what I missed. So that's great for both of us. Let's go more. No, what I mean is I'll explain a little bit more, okay? Let's look at that. Where is it? Okay. Yeah. Here's atom, right? This is a nucleus, right? And there's electrons, right? So now it doesn't have any meaning. But for example, the sun, it affects here, right? And it's gonna be a move affected the, the electrons comes here. As I said, there's no free electrons easily. You know what I mean? Barely sometimes, but theoretically there isn't free electrons, right? So it moves, right? We say moving this is a displacement, right? So nucleus is heavy, so it doesn't move. So inside of the dielectric, it gotta be like that. Okay. For example, DC source, switch, and then capacitor, right? AC. No, yeah, minus, there's plus. So this part is here inside, okay? So plus, minus, plus, right? So here's it gonna be plus, right? And minus here, right? But since, in the dielectric, there's exists many these of plus minus, right? Plus minus, plus minus, right? But look at that. Here's plus and here's minus. You make it, 0. And here's plus is 0. More specifically, right? Make it 0, 0. So in really important thing, in the surface over here, dielectric, like what I mean is the plate surface. Here's plate, right? Here's plate. Here's the dielectric. Here, surface part, only the electrons exist here. Okay. And then let's look at more. Okay. Look at that. We couldn't imagine the batteries, when it charges, it needs time, right? So look at that. The battery is a voltage, right? It's time. So gotta be like sorry. Yes. So when it charges it, you need time, right? And when you charge it, it's a there's no polarization happen. So which means look at that. Here's dielectric inside, right? Here's minus, plus, plus, plus. For example, sorry, okay. There's many of them. So here's a plus and here's a minus DC, right? No, here's a plus, here's a minus, sorry. So when it polarization started, when we try to charge it, the battery, it attracted here. When it's here, right? Attracted to here. And this is here, attract minus here. So this is charge. You know what I mean? And here, move, move, move. So, for example, when it charges, you know what I mean? The battery or cell phone, it's slowly goes by, right? When it charges 100%, here is 100%, right? So the polarization is done. That's it. The electrics. Yeah, I guess it's a perfect explanation to you guys understand this. Okay, let's see. Let's move on. Yeah, and the next step is, and the last part. Already we finished. Don't worry about it. So dielectric, there has a per minute permittivity, right? We say epsilon. So I'll explain it a bit. The dielectric is a physical quantity that indicates how much of a polarization occurs easily. So simple thinking. For example, small bowl and big bowl, right? We could, fill up the water here, a large amount, then here, small bowl, right? Same concept. You know what I mean? So how many electrons this material could make it? You know what I mean? Accepting the ability. You know what I mean? So as I said, how much of a projection occurs easily. You know what I mean? The numbers. That's it. And as you guys can see already, here's time, right? When it's charging, the capacitor is, just simply thinking is a battery, right? So here's, you look at it, you guys can slope, right? So when the first time you guys charging, the slope is sharp and more smooth. this. And when discharging, when you use the cell phone also, the battery is, the slope is sharp and gonna be more smooth. That's it. I hope you guys can understand this part. See you next class. Thank you.